Right. Good evening again, everyone. My name is Kim Ingram. I'm the Forest Stewardship Education Coordinator for UC Cooperative Extension. Thank you for joining us tonight for our Biochar Applications for Forest Landowners webinar. We have three sets of speakers tonight and look forward to hearing from them. We're going to start with Cindy. So Cindy, you have the ability to share. If you will go ahead and start sharing and you can introduce yourself. We'd appreciate it. And you are muted.
That's right. Always happens. Okay, so let me share my screen real quick. All right. I am Cindy, and I am the Woody Biomass and Forest Products Advisor with UCNR. I am based in Tuolumne County, and I cover several counties in the Central Sierra Nevada region, as well as statewide. I have some statewide responsibilities as well. So today, I will be talking about biochar, the general big picture of biochar in California, its status, the production, barriers, and future outlook. So first, I want to begin with biomass and bio-based products. Many of you probably already encountered or used some type of bio-based products in the past. So basically, biomass and bio-based products, it's in the name, they're bio-based. They usually use renewable, biodegradable materials such as wood, ag waste, and other, bio-based materials. So biomass products can be made into various products from what we see every day, like fuels, wood pellets, for example, composite board, and biochar, of course, and also biojet fuel can be made into bioenergy, and used as fuels for both plane and cars. And we also have another category is the wood products. And wood products have, of course, lumber. And we also have a category called mass timber, which is a large scale wood panel that can be used for structural components in buildings. So that includes a wide range of products like cross-laminated timber, glulam, and also other large-scale panels. But today, I will only focus on biochar. Oh, and there are more. I have more pictures. So yeah, so you can see you can use biomass on a lot of parts. We have a mulch, hydrogen. If you're interested in these products, can do some research, and we also have other events that will focus on these other biomass-based products. So, what is biochar? I want to start from the basics. So, biochar is basically a solid material obtained from the thermochemical conversion of biomass in an oxygen limited environment. That's very important. So it has to be oxygen limited in order to convert wood into biochar. So some of the key characteristics of biochar is that it resists decay for hundreds to thousands of years, um, and can contribute to carbon storage. And it has large surface area, and can be beneficial for maintaining nutrients in soils. And it also has the ability to retain nutrients and filter water contaminants as well. So that's why we often say that biochar is a good soil amendment. Um, so unlike ash or charcoal, where we use for when we have a barbecue, and biochar is specifically engineered for a soil application. So there are several common biochar production pathways. One is the industrial scale production, usually requires large scale gasification or pyrolysis plants, and with some large scale commercial equipment. It's usually these equipment in these facility there are usually high output and they also produce energy as a co-products. So that's a co-benefit of the a large scale industrial size biochar production facility. Um, but there are also various options for small scale biochar productions. For example, today later on in other presentations, you'll hear about the mobile kilns that can usually use. And there are also something called carbonator, and which can be used in a small farm or if you have a small piece of land. And the common mechanisms of these equipment, of course, like I mentioned before, have to be limited oxygen, creates a high temperature, and all these equipments need to protect the biomass from turning into ash, and either by isolation or flame quenching. So we need to be very careful when operating a kiln, and to make sure that doesn't happen. And a lot of the kilns and carbonizers, they're already designed that way to prevent the biomass from turning into ash. And we only keep the biochar at the end. So we can, by using these kilns properly, we can reduce smoke emission by over 90% compared to open slash pile burning. So that's another benefit of making biochar instead of just do slash pile burn. And biochar can be produced and used on site properly with if you mix with compost and chicken manure, for example. These are some pictures or examples of biochar production equipment. As you can see on the bottom left-hand side, that's a very large equipment, industrial size equipment. There's usually these equipment are pretty expensive and require a lot of technical training in order to operate them. But in the other diagrams, you can see these are either mobile carbonizer like BurnBot. Some of you might heard of BurnBot, and if you look at the lower right-hand side, you can see a kiln, which is a very commonly seen on-site kiln, mobile kiln that is fairly easy to assemble and use on site, and also comparatively would be the cheapest way for small landowners to use on site compared to all other options. So several things that I think everybody should know about biochar is that the soil that when applied properly, the soil water holding capacity can increase by 3.5 to 19%, depending on soil texture and application rate. And application rate and the soil quality is very important when considering a biochar. And multiple research study suggested that when the right application rate is used, and we will see the maximum benefit for of biochar from biochar. And so biochar is also the most effective when it's mixed with compost, especially in improving low quality coarse soils. So so higher quality, if you already have really good soil, you might not see biochar as as has that big of an impact. But if you have a low quality soil, the benefit can be very obvious. That's um, given that you apply the biochar properly and mix the biochar properly. And however, the impacts study also a lot of studies also suggested that the impacts on the crops yield is actually uncertain right now. So there haven't been studies shown that it has a very significant impact on the actual crops yield when used in agriculture. And also the quality and composition of biochar can vary greatly. So we really need to know, before you use biochar, you really need to know what you're looking for and the purpose, your goals, and what types of soil you already have, and what you wish to accomplish, before deciding, oh, what kind of biochar that I want to use, and whether it's really high quality ones or regular ones and what they're made of. So these are all things that we should be considering before applying biochar. And so that way, considering all these, the the uh, the benefit can be maximized. And so why don't we talk about biochar in California? So there are a lot of reasons. First of all, California generates millions of tons of biomass from forestry and agriculture every year. And removal and use of these of forest biomass plays a crucial role in California's statewide wildfire reduction goals. So we also in California, we have a high value agriculture sector as well. That means we generate various type of ag waste. And they usually they're also, just burned, just like forest slash pile. And the California Air Resource Board cited that, wildfire smoke in California costs the state around 2.3 billion every year, billion dollars every year in health related expenses. So that's another reason why wildfire reduction in California, it's one of the most um, crucial topics being discussed. And California also aims to achieve carbon neutrality by 2045. And biochar is recognized to be a carbon negative technology. And biochar's potential to improve water retention, address the state's drought and groundwater challenges as well. So California is a really good place to be considering biochar and the application of biochar. So moving on from that, I want to talk a little bit more about California carbon, the biochar market status, because that's something that's also very important to consider. So there are currently about 20 active biochar producers in California. Mostly are, small scale, and the feedstock, usually they're sort of consists of, softwood, nutshells, and some urban waste, as well, like backyard trimmings, for example. But in reality, the cost of production transportation can be really high, especially when you scale up the production. The production rate can cost a lot of money. And a carbon market right now in California which can be used to subsidize the cost of production is usually relatively low compared to the production cost. So, which is one important reason why we don't see many industrial scale production of biochar. But there are some recent changes. For example, EPA removed Title V permitting requirements for certain biochar producing system. And also, California, also in 2024, Senate Bill 1522 established a standardized definition for biochar products. And so these can promote the upscaling of biochar production and also the wider use of biochar in both forest restoration and agriculture. But there are a lot more to be done still. So these are some identified barriers that we see very commonly right now. First, of course, it's economic. So large-scale production costs are high, can range from $200 to $1,000 per ton. And carbon credits relatively low to attract high capital investment. And there are also regulatory barriers, and there's a very complex approval process for pyrolysis projects right now in the state. And the logistical problems is that the transportation can be costly due to the lack of local processing facilities and receiving facilities and specialized equipment for handling these low density wood materials. So when you add up these costs, the transportation cost, the removal cost, it can be a lot. And also public awareness, another important component, is the lack of knowledge and awareness regarding the best application methods for biochar for specific types of soils and crops. I think that's where extension outreach is really needed because like I mentioned before, if we were not applying biochar properly, and identifying the soil and the need of the soil first, either we don't see as much benefit, or it can even, cause some negative impact if they're not applied properly. So that alone can halt the progress of biochar utilization. And because of this, a good product, a good soil amendment, we can have negative perceptions toward a supposedly good soil amendment, which is a shame. So I think that's something that we really need to be aware of. And also, there's a lack of uniform standardized guidelines to produce biochar that's used for specific purposes. So there are many standards right now out there. NRCS, the Natural Resource Conservation, and also the international biochar initiatives. They all have their own standard and own guidelines for using biochar, but there's no uniform like one single fit for all guidelines right now. So which has caused a lot of confusions. So so there is a need for these standardized guidelines in order to prevent confusion and ensure that this good products can be used more widely. And I do have some recommendations for small landowners, I guess, and also small farmers to and is to reduce the conventional slash pile burning and consider making biochar an option. And also, I would say utilize biochar for replanting and water filtration on forest land is something to be considered and worth digging into. And also explore best practice for mixing biochar with manure compost. And if you get stuck or confused, and seek help from your local organizations like RCD or corporate extension offices. People, we can help you overcome these difficulties. And also always stay up to date on statewide policy and regulatory changes because who knows if the policies that change every day right now when it comes to biomass utilization. So some policy recommendations, I guess, would be from my perspective as a woody biomass person, is to streamline permitting to help biochar facilities navigate air quality and other requirements and also include biochar in the carbon market, such as cap and trade. Right now, biochar is included in the voluntary carbon market, so it's not mandatory. So it will be useful and helpful to include biochar in the carbon market as something that's standard. Also, some key takeaways I have here is that biochar is a technically viable tool for California's wastewater and climate challenges, especially for landowners and farmers. And scaling up production requires cost reduction and careful logistic planning. So biochar is not the ultimate solution to all problems, but it's a critical component in waste production reduction and also wildfire reduction, I should add. And there are more to explore. What are other viable uses of biochar on top of soil amendment? So cement, composite, asphalt, pavement. There's a lab at UC Davis who used biochar in the pavement, who makes biochar with cement and make pavement. And they have some very interesting studies that's coming out. So in the future, biochar may not just be a useful material in soils, but also in a lot of other things, like construction, roads. And yeah, that's all I have for now. Thank you very much.
Thanks, Cindy. All right, I'll have you stop sharing your screen and we'll queue Nadia up. I don't have any questions in the chat for you at the moment, but feel free to put them in as we go on to our next speaker. Nadia, are you ready?
Almost. Let's see. Did that work? Can you see my screen?
No, it's
No?
you have, oh, there we go. Now it's up. You're good.
Yes?
Yes.
Excellent. Hi, everyone. I'm Nadia Hamey. I'm a forester in the Santa Cruz Mountains, and I work as a forester on a 9,000-acre property owned by Peninsula Open Space Trust and Sempervirens Fund called San Vicente Redwoods, with a conservation easement held by Save the Redwoods League and public access managed by the Land Trust of Santa Cruz County. And I'm also involved in forest management at Swanton Pacific Ranch, Cal Poly San Luis Obispo's research forest. And in 2009, the Lockheed fire burned significant portions of both of those properties. Sorry, let me. So I'm going to tell you a story about those places. 11 years after the 2009 Lockheed fire in 2020, The CZU Lightning Complex fire raged through those properties again, and on the night that it blew up 40,000 acres under extreme fire weather conditions. And that fire burned without suppression at San Vicente Redwoods. It was a wind-driven fire when the north and west sides of the property burned, and backing fire with lower severity when the south side of the property burned. And here you can see burn severity map on the left with the red showing high severity and the green low severity, and then an air photo on the right with some of the immediate aftermath. The forest composition on those properties is mainly redwood and Douglas fir with tan oak and madrone and various live oak species mixed in. And the fire resulted in copious standing dead trees. While the redwood overwhelmingly survived the fire and is currently resprouting and regaining vigor, as you can see on the left, other species succumbed to extensive mortality from the fire, and in many locations, there are stands of wall-to-wall dead trees, up to 60 tons per acre of dead biomass in the forest that's fuel for the next fire. To reduce the fuel loading that would exacerbate the next wildfire and to re-secure fuel breaks along our strategic roads that are planned to be used as control lines for future wildfires suppression, or control lines for future prescribed burns that we plan to have, the landowners have embarked on aggressive fuel reduction campaigns. These are pictures along the Warrenella Road fuel break where dead trees were removed within 200 feet of the road on either side. Here I have a video. The standing dead volume averaged about 40 tons per acre. And this is one of several projects I've been involved in where we've employed incinerators, air curtain burners, and carbonators to consume the excess woody material. This particular fuel break stretched about 9 miles and resulted in approximately 17,000 tons of non-commercial fire-killed trees that were brought to one of 3 landings for processing. The project specs called for removing all the logs over 10 inches in diameter from the fuel break, and they were hauled with log trucks and dump trucks, which is what you're seeing here, to a biomass landing for incineration. And the residual slash was treated with a combination of pile burning, mastication, or lop and scatter to reduce the vertical and horizontal continuity and separate the fuels. Any merchantable logs were hauled off of the property and sold. Redwood logs without significant defect were not a big part of the project because they mostly survived the fire, but a few of them were removed for spacing and they were shipped to Big Creek Lumber Company. In addition, some Douglas fir logs were sold to a small local custom mill that manufactured them into beams and cants. The local firewood market is pretty saturated at this point, and so all of the non-merchantable logs were stacked at a biomass processing landing. And this is a picture of one of those. Our contractor, Ventana Forestry, then brought in a Carbonator 500, and the local CAL FIRE unit loaned us 3 S220 air curtain burners to process the material, which came in clutch. The carbonator, which is pictured here, is a type of incinerator that produces charcoal. I would say that the charcoal, I call it charcoal until it's inoculated with compost, at which point it becomes biochar. So mostly we're dealing with charcoal. The carbonator has a grate on the bottom with a conveyor belt below the firebox. And when the charcoal gets to be about the size of a fist, it falls through the grate and is misted on the conveyor belt with water to arrest pyrolysis. The carbonator uses about 6,000 gallons of water a day, and we found it to be most efficiently operated when it was being run 24 hours a day, since the heat up cool down process takes considerable time. The amount of biochar produced depends on a variety of factors. It depends on how the carbonator is run and how fast the conveyor belt is moving, as well as the size and the quality of the wood. And we found that charcoal production ranged between 2 and 10% of the volume of material incinerated in this machine, depending on those factors. Oh, here's a video of the conveyor belt running and biochar coming out, and it's slightly steaming because it's just been extinguished with the mist. The air curtain burners, on the other hand, are manufactured by Air Burner, and they don't produce much biochar or charcoal. Other than one specific model that I've been reading about called the Char Boss, which is manufactured for that purpose. Our S220 curtain burners have a motor like the carbonator that pumps air from the sill around the firebox that you can kind of see here, that makes a circulating air dome over the firebox and reburns the smoke to prevent particulates from leaving. It makes for a pretty clean burn, and when you see it in operation, you don't really see smoke, but mostly just a shimmering heat rising up. The air curtain burners don't have a bottom. The fire's directly on the dirt, and you can dig a hole to increase capacity below the burner before you put it down. We found there's not really much ash left over from this process. It burns about 3,000 degrees, and with the extreme heat in the firebox, nearly all the biomass is consumed. They actually come with rakes to clean them out from the door on one end, but we didn't really use those because they did not fill up with ash to any real extent. The material burns most efficiently when it's diced up into small pieces. So Ventana used a cut-to-length system to chop our logs into 6-foot chunks, and then this excavator with the large screw attachment to split the logs into smaller pieces before loading them into one of the burners. The carbonator produces or processes about 12 tons of biomass an hour in full production, and each air curtain burner can go through about 5 to 7 tons of biomass per hour. So the carbonator is about twice as productive as each curtain burner individually. The ideal processing site has about 100 feet of vegetation clearance around it to reduce the ignition from embers that come out of the firebox. And when the machine is being loaded, flaming chunks do come flying out of the machine when the air curtain is broken by the excavator and the logs being put in. In some cases, we installed a berm around the work area to catch sparks drifting in the downstream direction. And we generally used a water truck to water the work area daily. And we did have ignitions from the machine and just had to be vigilant in terms of extinguishing them so they didn't spread. Due to the heavy equipment needed to load the machines, the ideal operating window is during a dry period and not during saturated soil conditions. So operating during the winter we found to be pretty unpredictable, or the landing could turn into a muddy quagmire. The operation was permitted with a timber harvest plan, and we had an LE5 burn permit from CAL FIRE and a smoke management permit from the Monterey Bay Air Pollution Control District. The LE5 comes with terms for using the curtain burner during declared fire season, including burning only on permissive burn days, having 5,000 gallons of water on site dedicated for fire suppression, having an operator in attendance at all times when there's any heat in the burner, and monitoring weather conditions hourly while burning. Burning cannot start or continue if the maximum ambient air temperature exceeds 90 degrees Fahrenheit, or the maximum wind speed exceeds 5 miles per hour, which is often the case, or relative humidity falls below 30%. Therefore, the shoulder seasons, the fall and the spring, are the best time of year to operate. And during the summer, we would essentially work on stockpiling material to burn. The older carbonators have water effluent that comes from misting on the conveyor belt and needs to be managed on the landing, like you're seeing here. However, so this is one of the old ROI carbonator 500s. The newer TigerCat 6040 carbonator models, I understand, require less water daily because they can recirculate it. And also there's less to deal with than on the landing. Both types of machines are large and difficult to move. The carbonator is on tracks. And as you can see here, once it's on a forest road, it can be maneuvered with a remote control, which is pretty snazzy. The air curtain burner can be dragged around on a landing and transported on a lowboy, like you see here, between processing sites. And some pretty heavy duty equipment, a crane or a large excavator or large cat, is necessary to load and unload these machines. And maybe some bridges are also not suitable. The carbonator weighs about 83,000 pounds. Processing costs can range widely. As you saw in Cindy's presentation, I think she said $200 to $1,000 a ton. In our experience, we've pulled off projects for between $12 and $70 a ton, depending on a variety of factors. Having more machines, like the 4 that I have been, 3 curtain burners and 1 carbonator, all operating at the same time, 24 hours a day with a light bank, has enabled us to reduce costs significantly. And the process of cutting and hauling the material is an additional expense. Our projects have been reliant on grant funding for the most part, and biomass processing, especially for the biomass processing phase. The carbon life cycle is a compelling reason that we have been able to secure some funding to use this machine. We haven't found a market for the biochar really to help offset costs, but we're working on it. We've given away truckloads of charcoal to a few local farms, including some large organic operations like Jacob's Farm Del Cabo and Lakeside Organics. One of them had the charcoal tested at a lab for its chemical properties, and the pH value of our sample was 8.1. It's an excellent soil amendment, as Cindy mentioned, and enhances moisture retention and is great for mycorrhizal development, especially in more clayey soils. Agricultural producers from the Salinas Valley have expressed interest in our charcoal to treat wash water from lettuce facilities to sequester phosphates from that water. And the city of Watsonville has also expressed interest in biochar to clean up urban and agricultural runoff. So if used correctly, it can kind of act like a massive Brita, which is pretty cool. As far as I'm concerned, charcoal is like black gold, and if I could figure out a way to spread it in the woods without undue disturbance, I certainly would. And here I have some more pictures of some of the biomass landings full of logs to be processed. And to date, I think that we've gone through about 30,000 tons from a variety of projects at San Vicente Redwoods and Swanton Pacific Ranch. And that is all I have for the moment.
Great. Thanks, Nadia.
Welcome.
All right. I don't see any questions in the chat at the moment, but again, folks, feel free to put them in. Cindy's already answered one in the chat. So with that, Tabor, I'll turn it over to you all. And if you introduce yourself and share your screen.
Hi, I'm Tabor Teachout, president of Biochar Coalition, and Kenneth Scherer is going to share his screen, and I'll let him introduce himself if he's here. But here's our intro. If you get it in presentation mode, there you go. So I'm on the top there with my livestock and my hamlet in the fire, and Ken is down below, filthy and black, working in Warner Valley. We're Biochar Coalition, Biofuels Reduction and Forest Health. I'm the president. Ken is the executive director.
That's right.
And our mission is to reduce biomass, fire fuels threats with less smoke, less ash, converting into high quality biochar, and less time committing to on-site carbon sequestration. And the purpose is to increase biochar making for stables carbon sequestration, creating more biochar by educating and training more people in how to properly make and incorporate biochar into landscapes, to sequester stable carbon, reducing atmospheric carbon, and increasing soil carbon, protecting watersheds, while addressing our current global carbon imbalance for the benefit of future generations of all biological life. That is our purpose and mission statement.
And that's a very large amount of words there. It's just our purpose is very important to us. So we just want to make sure everyone hears that we definitely do biochar a bit different than a lot of other people we've seen. And we're just going to go through this and give you guys a run through of what
we are a 501c3 nonprofit as well. And so here, you can see we got the map on the left is all the different places, and you can find that on our website, all the different places we've located and done workshops in different communities, as well as a certificate of completion. As what the first deployment on the right is the Warner Valley, where we trained 15 Maidu natives, and they were the first certification crew where they were all certified basic, but many of them were intermediate, and one of them made it to an advanced certification status. Below, you'll see a picture of a group of people. All these people came to a couple workshops, and all those people are looking for jobs. They all want to get paid to make biochar. So there's a work crew out there for sure. And on the right in the lower corners, the picture I like, which I also have behind me on my background, is 5 kilns lined up in a row in an orchard. It's our first orchard project, the first 5 kilns all piled together. The most kilns we've operated is 8 kilns at a time, and we've also combined multiple kilns into larger kilns, making 5 kilns, but they were much larger than standard kilns. Now, making biochar can be done with or without a kiln. What we have is the carbon of the plant is 50% of the entire plant is carbon, and that's actually 47.5%, but we round up to 50 in our story. And in that 50% carbon, it's referring to the carcass weight of there's the video of the walnut orchard conversion. We did 4 rows of trees, 2 rows of kilns burning, 2 different days of work. And this is a proof of concept. We want to scale up this model of production where we have multiple kilns and multiple crews creating more work and more biochar. Now, the carbon of a living plant, half of all that carbon is released into the soil as an exude, as a sugar, that sap that leaves the roots of the plant in exchange with mycelium for other nutrients and water. So the carcass weight of the dead plant is 47 and a half, or roughly 50% carbon that's in the plant. But we can't retain all of that through combustion. We release half of it. So the way I describe it is, if you look at the cell structure of a plant, the cell walls are carbon bonded with hydrogen to make the cell wall, and the cell sugar content is carbon mixed with oxygen, hydrogen, sulfur, nitrogen, phosphorus, potassium, all the other elements that are in our plants. So when we're talking about making biochar, we're talking about burning off the volatile sugars, the contents within the cells. And what you're left behind with is the cell wall structure. And as soon as there's no longer any volatile oils, the red hot coals will no longer smoke and they'll no longer flame, and we apply water and quench it. So the elongated photo in the middle is the crew of the Maidu tribe doing the quenching of the kiln, and on the right is the time-lapse video we did, which consists of two kilns set up on opposite sides of a pile of brush. This is all the branches of 3 pine trees. So 3 pine trees were dropped, and the logs were removed for taken to a mill, and the piles of branches were just left there from 3 trees. And we were asked to get rid of it, and they were still green, and we set a kiln up on either side. You can't see it at the beginning because that pile's so tall, but once it gets done, you can see the second kiln in the background gets quenched first before it gets dark out. And so we made 2 piles of biochar, and it was probably, I would say, 4 cubic yards. So one kiln full can make about 3 cubic yards of charcoal, and 3 kilnfuls can make 1 metric ton of charcoal, which is equivalent to a metric ton of carbon, because it's 95% carbon and 5% mineral that otherwise would become ash. And so when we're converting a ton of charcoal, we're actually reducing 3 tons of carbon dioxide emissions. And a lot, we do generate some smoke in here, but the amount of, it's called a flame cap kiln, because as long as we can keep the flame cap, the flame consumes oxygen. If oxygen can't get to the bottom, and you can see this photo on the left, that smoke is actually going down into the flame. The heat of the fire pulls the smoke down into it. And so the mechanics are that we're creating a flame cap, and the flame consumes oxygen. Oxygen bonding with carbon makes carbon dioxide. So when we make a fire, we are always making carbon dioxide. So just because you have a smoke-free fire does not mean you have a zero emissions fire, because the emissions of carbon dioxide are odorless and invisible. But the smoke is emissions beyond carbon dioxide. There's a lot of hydrocarbons in there and the volatile nutrients that are in the sugar content. And the smoke is meaning it's not hot enough to reach combustion, but the heat of the kiln is so hot, it'll actually pull the smoke down into it. And so to create charcoal, you want to have your coals red hot without any smoke and without any no smoke and no flame. And if there's no smoke or no flame, we add water and we quench it. And so the cell structures, there's about 24% of the plant is cell wall. That's what's available. Because we operate an open flame cap kiln, we do get some ash formation no matter what. And therefore, we can really only retain about 20% of what was available of the carbon, whereas the carbonizers, as they mentioned, they're getting about 2% is what's a common thing, 2 to 10 they'll say, but that's half to less than a 10% of what we're actually able to retain. And that's using the flame cap method, because the kiln, you can use a pit, not have to purchase a kiln. That kiln, the Ring of Fire, is like a $2,000 kiln right now, commercially available. But the earthen pit is how we learned and how we started, and that's just an earthen kiln, an earthen flame cap.
And I just want to say that we also been running, when we first started using these apparatuses, they were being called burn barrels at first. So we just had to clear that up with some of the air boards and some of the jurisdictions where they want to kind of shut that down. But we explained, showed them the diagrams, gave them the lowdown on what we're trying to accomplish, that these are expensive burn barrels, so to say. And we just demonstrated them in front of a lot of county air boards, and they all agreed that we were abiding to the climate action plans that were set forward for the state and for our 2030 agenda that we have here to get rid of greenhouse gases. So they agreed, and we were able to
And
showcase that.
a burned barrel is letting the oxygen in at the bottom where the kiln is not. Here we had the opportunity with Sierra Streams Institute brought us some thermocouplers to an event, and they put it in the kiln, and you can see the ranges at peak ignition. We pretty much spiked it around 2,000 degrees, 2,100 at most, and and then it tapered back down to 600 degrees is kind of the lower end of where the charcoal sits at the bottom. But as the charcoal builds up, it insulates the heat from the ground. So the heat gets further and further from the ground, the fuller and fuller the kiln gets. The heat can't radiate down because the charcoal itself acts as insulation. So we actually reduce having any sort of a burn scar from making a pile, where a standard pile burn would actually create a burn scar because the heat goes in all directions. And as the coals sit and radiate on the ground, they continue to cook the temperature down deeper and deeper, killing soil microbes. And after open fires, you will end up having nothing living on the landscape. Whereas with the flame cap kiln, you can have grass growing the same season just by raking the charcoal away to give room for the grass to see the sun.
And
And
through this demo, we were able to really hone in on the quality and the characteristics of our biochar, because knowing what temperatures you're at within the unit gives us better understanding on how the properties of the charcoal is going to be. I know we say biochar or charcoal, like Nadia had said earlier, but we're creating carbon to be biological. I think that's why they had named it that, but I agree that it's not bio until it's got biology. Absolutely. So we're showing here that different feedstocks and different temperatures create different types of biochar. And as more people learn of what carbon is and how it's made, and the artisanal methods of making biochar, temperatures will become a very important aspect of what carbon we're going to be using within our soils, because higher big chars have higher CEC potentials, carbon citation exchange rates higher than let's say a 600 or 300 Celsius biochar, but they're finding out some of the best structures of carbon are between 900 and 1200 degrees. And as you get higher, you start melting the structures of them. But it's a lot of this is up in the air. And as we explore and gain more continuity with our research and education and field trials, we'll be able to dial in what we know is best. And we're excited to be a part of that with our field-based deployments.
yeah, and why what we do matters is because if you don't understand the process of the flame cap method, trying to get to an air curtain burner, you could essentially spend your day blowing smoke. And as you can see on the left, this is Yreka's burn boss that they or air burner that they purchased specifically to reduce emissions and smoke in the Yreka community. But this is actually how it's being operated. So they spend their day burning, and this bellowed smoke lingers in the Yreka Valley, polluting the entire community, the same as it had been when it was just pile burning. And on the lower center, you can see this is a ring of fire kiln. Now, those are the kilns that we tend to use, but even we can make a bellowing smoke as a result of not understanding the mechanics of the flame operation. And so if you look in the upper right photo, we have the kiln in, a good flame combustion. But if you look behind the gentleman throwing wood in, you can see there's a smoky pile because we did that demonstration right alongside a standard pile burn. And so they are in the background burning a pile of wood, and it's just generating a bunch of smoke. And we're burning equal, if not more, wood in our kiln, and we're not generating any smoke. So the use of the kiln does not eliminate smoke. It's the technicians that eliminate smoke. The video on the left is one of my favorite for the showing the production of biochar conversion as we do it as fire fuels reduction on the landscape in place. Um, Unfortunately, the camera battery died and we were unable to capture the scene where we rake out the black charcoal. So I'm always bummed about that. But I love seeing it cleared and how fast. And then when it restarts, you'll see it's how much was originally there. And that's 1 day's of work, 3 guys and 2 of us primarily and the landowner. And that biochar is going to be used right there on site. That little building behind us is actually his outhouse. So he uses the biochar to poop on and pee on. And so it's used to manage his fertility waste. And on the right is a video of the workshop our second workshop that we did in Nevada County in North San Juan area. And this was a great attendance. We had a pile of wood and a pile of Scotch broom. We ended up leaving the wood and doing just the Scotch broom so that we could get to complete combustion and quench before everybody lost interest in being there. And you can see I'm standing fairly central, and I stand there most of the day, and Ken is on the right running around and tossing brush in the kiln. And this was the day I really stopped saying this is a no smoke kiln because we had bellowing smoke right as I'm about to say that. And so we've learned to say that we are reduced smoke. We don't eliminate the smoke, we just reduce it. And so this is what a workshop looks like. All these people come, nobody knows what carbon is or what biochar is, and we spend the time talking about it while showing how we convert it with the Ring of Fire kiln. And then we go through a process of quenching it. And Ken will bring his insect frass because he raises bugs. I raise sheep and cattle. And then he'll apply some frass onto the charcoal so it becomes enriched. And that spot on the ground today is the tallest luscious grass on that hillscape. And the other pile of brush we burned on another day. So we have done 3 piles on this hillside now. And it's at a public park between a school and a public park. And so there
And
you
that,
have it.
that's how we like to put the biochar back into the soil and back to where it came from, is building this carbon legacy of the existing or the residues left over from the tree that had fallen down and incorporating it back into, as soon as the session begins, as soon as we put this charcoal and spread it out at 1 inch and you saw that dust, and then we spray in some fertility, and then we're done with that. And we'll have some photos of that. And we just say it's more people, more kilns, more wood, more heat, more time, more water. We'll have more charcoal. And that's the goal with what our organization is. Many people make light work, and there's utilities for every single thing we can do to make as much charcoal as we possibly can. And so here's a case study where we had finally gotten a good break to get a large scale operation together. We did it with the Mountain Maidu Summit, or the Maidu Summit Consortium. They're a nonprofit of the Mountain Maidu. We were able to pretty open about what things cost. We secured about $110,000.
Funded by the Dixie Fire Collaborative?
Correct. Yeah, the Dixie Fire Collaborative had generously, we had submitted a proposal to them for some of the landowners there. And I just feel like we got really lucky there to get this done. And we were able to get 15 people trained. We offered about 112 hours, about 16 days, 16 full days of work. And we were able to treat about 10 acres. We got about 2 to 4 yards per kiln. Definitely had at least 40 kilns launched. And from those totals, I was able to come up with the parameters of what we had created, which was about, I say high end, because we definitely really did do 40 kilns. So I say 160 yards we made, and we probably reduced about 336 tons of biomass in 14 days. That's pretty good with these guys. They were workhorses.
And these were whole trees. So we were chainsawing them into sections and splitting them and throwing them in some cases, they weren't getting split. They were just being cut to be short enough to fit in the kiln.
And that was the best part, is we just needed materials and machines that were already pre-existing. We didn't have to bring in an army of machines. We just had an army of people with log splitters, chainsaws, PPE, firefighting equipment, trucks, water tenders, rakes, shovels, pretty much basic things that we all have as a community. So it was able to come together and equip everybody to start reducing the fire fuels threat on site in the middle of Warner Valley. I don't know if anybody knows where Warner Valley is, but it's a pretty remote area within Chester. Not many people visit there. It's right near Drake's Bad, right above Lassen Peak. It's been, these landowners have said it's very difficult to get anybody out there to work, but we showed up and we got a lot done. We have a
And we did it
crew.
with existing resources. We had already kilns in possession. We already had tools in possession, so there was no equipment investment to keep it going. But there is to scale up further.
Right, and it's the what we want to definitely see is more grants being written to help assist this type of community scale biomass treatments. We love Tiger Cats, we love what they're doing, but we see the utility in having a lot of kilns out there, thousands of kilns, thousands of operators handling sensitive areas that we can't get into that need still this treatment. So we have trained biomass crews, they're our main staple in what we do. They're the big heavy lifters. We got the kiln boss, someone who's over 100 plus successful kiln burns, thousands of hours of operation. That would be me and Tabor. We're considered kiln bosses on our own right. And then we have the kiln boss assistant. That's people within our group who have demonstrated their capacities, such as that one Native woman, Raquel. She was fantastic. We would definitely consider people like that who are more apt to burning and understanding that they are brought under the kiln assistant wing. And we also discuss safety at these meetings and explain the kiln. Here's a schematic we created to demonstrate the sensitive areas around the kiln. Near the kiln, we call that the red zone. That's where you don't want to stand out. You don't want to.
It's
You don't want
actually
to stand
fairly
there.
safe to duck down in the red zone to pick up any debris that's falling in there, but any flame in the red zone is going to go towards the kiln because of the thermodynamics of the heat shield. But if you stand at the red zone, it's your face that's vulnerable to the heat, which is why you'll see me wearing the helmet. Although it's plastic, it has a face shield for like chainsaws, and the face shield dramatically reduces the heat directly to my face so that I can actually look in the kiln to monitor the rate of its combustion, where the
And we
green
train
zone
a
it's
lot of
safe.
our crews to manage the red zone. We want everyone to make sure that we aren't losing control, because what's great about these kilns is they create their own pressure. So any fire that does fly out into the red zone is going to be sucked. It's going to become a backing fire instantly within that first 10 to 15 feet. So you have quite a bit of time to handle the threat. But generally, we don't have that even happening because everything's raked out and we're operating pretty safe and standard burn. Oops, I just skipped a slide. Nice. Got to go back. My apologies. Doo-doo-doo.
Yeah, and so some of the concern about the question about whether charcoal is considered biochar, the way I would consider it is if the charcoal is able to absorb water, it's able to absorb biology. So if the charcoal still had residual oils in it, then it would have been smoking or flaming in a pile, and that's just charcoal. But if the charcoal wasn't smoking and it wasn't flaming, then it's burned off all the volatile oil, so it's able to receive biology. Even if it doesn't have it when we make it, we still refer to it as biochar because it's able to receive biology, and we're going to put it where we intend it to. But it does need the biology activation for it to be what we understand as biochar, but it's still called biochar even without the biology if it's able to receive biology compared to charcoal that isn't able. Here's Ken's drawing and plans for how we lay out a crew, all the yellow spots inside the red treatment zone. The yellow spots are where we anticipate putting kilns. Where there's less brush, there's more space between the kilns, and where there's denser brush, the kilns are about maybe 100 feet apart. And so, a few people can operate multiple kilns. And so you're just going to stagger them so everybody can see in between each kiln so you don't have any fire fall on the ground and spreading. Although
And
doing
this is
ground fires alongside is also acceptable.
and this is just your standard LE5 burn permit plan. They want this structure in a way that shows that we have our aptitudes together for we can burn off the on the off season. This we're trying to burn in October, trying to get ahead of the weather, and so we had to make these pretty elaborate plans. A lot of people are used to them by now. A lot of people who are in this road, LE5, LE7, LE62s. It's just part of being a burner. And we had, I think this was the first big LE5 kiln burn that might have been ever been done in California. I don't know, but it took me a while, so I want to make sure we got this thing right, and it got approved. We were very thankful. Just had to pay our burn permits. Permitting with kilns is pretty simple. It's just an LE5 because we're burning bigger than 4x4. They make kilns that don't need an LE5, such as the Flame Wise. So you do have
Flame ones.
options. Flame
Yeah.
Wise kilns, excuse me.
That's a
And
great home model.
it's a home model. It's great. And it's just, everything we do has to be permitted and everything has to follow regulatory alignment. So making sure you get insurance and all that. Insurance for burning and running chainsaws is extensive, but we have been able to find ways to make sure other people take that liability while we just run the kilns. So that's just, business is business. So I'm just excited that California offers these super easy ways for us to just work within the frameworking instead of having to change everything. We can just apply for the LE5 and burn pretty much anywhere we want, which is great because that's what we do. We can deploy anywhere. Tabor, you want to talk about your
Yeah,
your
so
yard?
this is on the lower left is me in one of our first kilns that we did in the public, and it was just a pit, an earthen pit. So with a shovel, I can dig that pit anywhere. If you dig a hole and you dig a pit, it's not legal in California because if you ignite a tree's root mass, you create an underground fire that's unstoppable. So if you dig a pit and there's a root crown, you should fill the pit back in. You can only successfully do a pit where it's true earth and clay and no biomass roots mass to ignite. In the center, you'll see my car. That's a Yaris, Toyota Yaris, and I just have that's a Ring of Fire kiln mounted on the roof of it. So anywhere I can get that car, I can get that kiln. And if it's once I get parked, I can hike it up. In Nevada City, I took it to a slope that was incredibly steep. I had to put the kiln on my head and balance it and just hike up the hill. It's amazing, but I can take it anywhere. On the right was a public park next to the pit, actually, where this woman in the foreground, she's got a Scotch broom puller because there's a lot of that Scotch broom was primarily what we burned. And in the background on the right, you can see those are her sons that are actively doing a prescribed burn. They had already had prescribed burn experience, so we let them go at it, and they did the fire on the ground around it. And the center picture in the top is the Warner Valley project. So those are the native working, and you can just see how dense that dead tree mass is. Those are whole trees of various sizes, from 2 inches to 12 inches or more, and all of it just got cut down and bucked up and tossed into that kiln, and we converted it right there on site and left a big black circle. And that kiln in the top center is about 6 panels, I believe, which is twice the size of kiln as what's in the foreground is, I think, a 4 or 5 panel kiln, and they sell them as 6 panels, so they're adjustable in size, and you adjust them based on the amount of biomass. So if you have a huge volume of biomass in a same location, you can just make the kiln larger in diameter. But if you don't have a large pile, it actually is more efficient to shrink the kiln size, because then the heat rises closer and it burns actually a bit faster, and you'll get a higher volume in that size if you can fill it up. But then you're done quicker if you get it all in there and you set up more kilns. Yeah, this is just intense. Like Warner Valley is depressing for me to see just the devastation of the forest, but it was really inspiring, and really I do this to combat my ecological depression, to make this improvement, and to see this crew take to the kilns was really fun for me. I loved watching them take to it and learn about it, and they want to do more of it, so we want to get them more work. And so here you can see the kiln on the left. You can see the size of some of those logs that are in there. I mean, we just put whole log pieces in there. And on the right, you can see that's the piles of char. There's some rounds on the ground still. There's some pieces. So there was left some biomass that's not volatile. Most of the small stuff's in there, but there's some rounds on the ground. There's firewood split for the landowner.
But
And
we
we
really got it cleaned
specifically
up.
left standing dead for habitat for birds and bees. Ken, did you say?
Yeah, we really got that area cleaned up. I mean, we worked. That place only took 5 or 6 days for us to make that fire break for that woman, and now it's got charcoal and it's get soaked and saturated now in the snow that we're receiving up there and the wetness. So it's going to carry over, and through succession in the years, eventually that water table will be able to replenish a bit faster than it used to. And that's just some of the lessons we've learned from our live operations. You'll see some of these photos
On the
when we
lower
work.
right's the orchard completion. You can see that those were piles of trees. The only thing left are the big root balls that we couldn't have managed. And but all the charcoals, you can see the circles down the line. So we did 2 rows like that. That's just 1 row. A story on the left is actually we did a workshop at Durham Wood, which is a wood processing plant And it started raining that day, and in that kiln, we're actually just raking it straight into the water. The water just filled up several inches around the kiln, and so we just opened the kiln up and just raked the kiln into the water. It was pretty amazing, and ultimately the whole little landscape flooded, and the charcoal all floated over to one corner and absorbed a bunch of the nutrients from the wood compost that they're making. And the landowner ended up making it, tractoring it into his cement slab he was building. So it's actually been sequestered further into concrete. And the upper right is more of the Warner Valley project, where we actually hired a water truck to come help us quench in some of the areas on some of the event days. And yeah, so we've
Yeah, it
been.
just shows us a lot about what it takes to be at a higher level. Because a lot of, I'm not settling with just one kiln at one time. I want to do this landscape scale. So it came with a lot of learning, a lot of mapping, production bottlenecks, learning the skills and the challenges of working with people who really don't know anything. Because this 15 operation, these guys did not know anything about the kiln. We had to literally give them from 0 to 60. We had to be ready to go and rock and roll because we had deliverables. We were ready in 3 days to be at full production, which we got them up to 4 to 5 kilns after the fourth or fifth day. And then we were really rolling and getting some reduction done. And these guys knew the plan, knew where to go, where to stand, how to set these kilns up, dispatching, not losing wing nuts. And it was just incredible learning experience. And we're hoping to get more of that dialed in to get more of this community scale biochar making. And what we love the most about the biochar, what I personally love most is to seeing the soil benefits. And after a few years of it being on the ground, we return back to our sites. You'll see on the right, we had dispatched some wattles. I believe Cindy and all of us, that was when we were
It's in
there
Placerville at the
at
fairground.
Placerville. Yeah.
And it's overflow at the pond. So that's a 12-inch wattle that's packed full of charcoal we made at a workshop in the Placerville Fairgrounds. And the ones on the left, you can see there were black circles that are growing over it. We love to go back and just see the vegetation. That one in the center, it's like it's almost only green where there was charcoal and no green around it. So for me, where that works in great is when you get that regrowth and it starts coming back. That's where grazing comes in for me. I was a livestock grazer before I got into biochar advocacy, and I now would go back to these sites and graze the vegetative overgrowth. And by having the animals on those piles, they're adding their manure and urine to increase the biology and development. So again, biochar, if left on the landscape raw, will in time absorb biology naturally. But if you intend to put it into a garden, you do need to enrich it directly, whether through compost or Hebrew
And that's
suggestions.
where what Tabor says that we really do want to integrate these carbonizing practices more into existing forestry programs. There's so much that we can retrofit. There's timber harvest plans. There's climate action plans. There's hazard mitigation plans. There's so many plans that we could retrofit carbonizing and make it a bit more, assertive, like in WLPZs, or maybe we can't drive a front loader down that class 3, class 2, or class 1 stream. Maybe we have to actually walk the kiln down there and take care of the biomass because we have an endangered species or we have archaeological sites, things like that, where we can really niche be written into timber harvest plans, especially thinning projects. It absolutely breaks my heart to see so many slash projects just torching everything off into ash and thinking, man, if we had just made some of that 10% of that into carbon, we'd be better off as a community, as a species, as land stewards. And we're not saying we're not neurotic about what we got to do. It's like where it makes sense and where it doesn't make sense. We're not advocating for everyone. Like we get it. Sometimes things just got to get done and whatnot. But let's just
So,
think about where it can be used.
and you can get 10% of biochar from a pile burn. It's more smoke effective to have less smoke if you ignite a pile on the top rather than on the bottom. And that's just for emissions control for and igniting any People can learn to put their kindling and pine needles and pine cones up at the top of the pile to get ignition. You'll have less smoke for the tire combustion. The other thing is to not add any more wood once you've ignited the fire, because any wood you add is cold, and by the time it's cool enough you can approach the fire to add wood, it's almost done. And you should not add wood, and use a pitchfork and rake out any incomplete wood that's still smoking or still flaming and set it to the side. By setting it out to the side, you've cleared out incomplete wood from the pile you started and burned. And then if you apply water, and if you don't have easy access to water, you can use dirt, and dirt will successfully quench. One day we didn't have water at Warner Valley because the trailer needed some kind of repair, and they didn't show up. And by the time they showed up, it was too late. We had already made an executive decision, and we had 15 guys with shovels shoveling dirt into the kiln, and we were managing to quench 4 full kilns with just dirt. And it was a successful quench because dirt will cool it down. 350 degrees is the magic temperature. Once the carbon is less than 350 degrees, oxygen can no longer bond to it. And so you can make a 10% pile just by quenching it, having a few sticks incomplete in there. But you can push it to a 12% pile by using a pitchfork, removing incompletes, allowing it to burn in a secondary pile, and then quenching the secondary pile when it's done flaming and smoking.
And we also discovered that the cost, like the economics of converting biomass into biochar, is pretty much the same as pile burning. It's like around $70 to $120 a ton.
Also
So
comparable to chipper shredders. If they
chipper and
pile it
shredders.
for a chipper, they've piled it perfectly for a kiln.
So when we look at economics, like what's the value of smoke? Because we said it's about what, 2 billion a year of damages of health concerns, I believe, at the beginning of this. So what is the true value of what we're doing at the end? What's the life cycle assessment of our operations versus just standard practices? Like this is a big gut question we need to ask ourselves going into the future for forest health and forest management.
And so like when you were to compare like a flame cap kiln to the tiger cat, like 3 flame cap kilns can produce the volume of a tiger cat in biochar in an 8-hour work session. But in order to meet the scale of their fuels reduction, because they're reducing 5 times as much fuel, so we would need to increase the number of kilns to, 15 to 30 kilns in order to compete per day with the volume of biomass converted. But the difference there is 30 kilns is 30 people that are employed, where the Tiger Cat is operating maybe 3 people and 4 kilns and 24 hours. And I don't want to work 24 hours. I want to sleep. And I don't know many people that want to work. I don't want to train 30 people to work at night either. So we would still work a regular day hours, but our vision is to increase more jobs, more people able to make biochar. And using the flame cap kiln and a distributed network on site, we can reduce emissions from transporting biomass. In tractors, we don't need any of that. If we want to try to do whole log decks, we do need some bigger machines that they piled in with the machine. We can't unpile it by hand. And we would use a machine to split the wood, because splitting the wood, as they discovered with the Tiger Cats and the carbonizer as well, is by splitting the wood, you end up with a quicker rate of combustion and a more efficient burn. And if you cut them down to pieces we can pick up by hand, we can labor manage it and throw it into the kiln and create jobs doing that, which is boosting our local economy. And so here's all of our links. You can find us on LinkedIn, Instagram, Facebook, YouTube. I think we're even on TikTok. We're socially trying to get out there and show what we're doing and share what we're doing, and encourage people to do so. So please reach out if you have an interest in having another Zoom meeting in another group or community. Let us know. If you want to do a work demonstration, we look forward to seeing you in the one that we have coming. But reach out to us so we can organize more. And yeah, I'm really excited. This is one of our best pictures of Ken and I working at a biochar pile. We just really get into it. And so. And this is, if you wanted to do references, Ken put references to some of the slides and information out there.
And
So
that's all I really have. I just want to say thank you to everyone at UCNR for letting us give this presentation, and all the viewers here today. I just want to give a big shout out to everyone. Thank you.
Well, thank you all of our speakers tonight for presenting. We appreciate that. And I'm going to go ahead and stop the recording.